Okay. Uh, I think the exact equation we already have examples, and I think the way you see the differential equation now, you will have options. Okay, which way you are going through. We have several techniques. From the first one, the separable, linear differential, and then the exact equation. At least three steps to check. Okay? The separable one, the most obvious one that you can try to check, and the most simplest one. I think the simplest one. I think that's easy. The easy way to check the separable one. However, the linear and the exact equation, you can sometimes the equation can be solved in between these two options. Okay? And I believe it's up to you. It depends on you which method you prefer, unless the question's asking the specific method. But if it is not asking any specific method, you can uh, choose which method you prefer. Okay. Now, I believe in your homework you have some questions. I think on the last two questions is about the techniques. I, I think um, I think that the tedious one is the integration one because you need to review your integral note. Okay, so you need to have some techniques from your calculus to solve. So I hope you still have your notes, and I think you can just review, okay, the integration. I will give maybe some hint or some explanation on some questions on your homework. Okay, the first one is probably because I think some of you asking on the solution of interval. What is the interval in those questions means? Okay, if you remember I think the second question, you have uh, this c like that, and you have the differential equation like this, and then you need to find solution with some initial value, right? And then you also have this, and then you need to also determine the interval, right? So the thing is, you can solve in many ways you can, and because it's homework, you can also draw the graph with GeoGebra if you want to check how the graph will be. So the first thing, we are going just to check the initial value. Okay, check the initial value. So when we have the maybe let me use dark blue. So when we have this one uh, x squared plus c, with initial value, we can write down that we are going to have for the first one. Maybe let me separate this to here. So we are going to have, so this will be here. Okay. So according to initial value, this we can have, and we can find c, right? If you solve this, you know that c will be -1. So maybe you can try to draw first the equation, what it looks like. And then if you already have drawing that, and remember, okay, domain is important here. Domain x squared is not equal 1, right? So when we have the points that your solution should have is on this 2.1 over 3, right? 2.1 over 3, according to your domain, is on the right side. So if you draw if you draw the function, or maybe just draw the line numbers. Well, 2 is around here, right? And if you think, well, just through some logic reasoning, what will happen here? Maybe we have curve, curve, and this will be some asymptote, right? So the only way that the solution curve will be is only this side, right? Only this interval, okay? So you don't need to care much about this other two. Okay. Well, there is another solution here, but our points, the 2, 1 over 3 is on this side. So we only see the solution curve, okay? So remember, what we are going to have, or our goal, so our objectives, we need to find the curve that fit in with our point. Okay? The same way with the second one, you will see that we have some domain, we will have some interval, and for the second one, let me just get you to here. So from this, so actually this is just checking the points, and if you want to look at the graph, you can check the graph just to make sure we familiarize with the equation and so on. So we are going to have, this will be -4, and then 1 over 4 plus c. So we solve this, we get c is -2, 1 over 2. Okay. Now from the equations, then this going to be 1 over 2. And if we, the same way we did, we are going to have, at least the x squared is not equal half, right? That's our domain. So we are going to have, well, this, right, and this. Now the question is, where does the points lie? The points is 1 over 2. 1 over 2 is in the middle. Okay. If you check the graph, it will be in the middle. So the solution curve that fit with the point is on this, between these two intervals. So that's the solution interval. Okay. So you need to write the interval. The left one will be from 1 to infinity, and this one is between these two. Okay. Okay, and then I think number 3 and number 4 should be okay. Not really complicated, I think. Number 5, need to have some integration by parts. I think that's one thing that needs to be emphasized. I think I will focus on number, let's see. Oh, number 6, the second one. Okay, I believe one student asked me on Tuesday class, and yeah, I think what he did is okay, and that's the correct one. So this is number 2, homework. Okay, so number 6, I will give you the answer key later, okay, in the Moodle for the whole homework. Okay, now perhaps we are dealing with, maybe we need to have switch the dx going to here, and we have dy over dx. But if you look closely and when you try to solve it, it's not easy to solve if we have the dy over dx. Okay. Because we have trouble when we try to expand this and try to rewrite the form and make out the structure. Either try to take separations or try to make the linear differential form. It will be, I think, quite difficult to see. But we are not sure which one is independent variable and dependent variable, right? And we can make our own assumptions for this question. Okay? So we can make assumptions that, so assume that the x become our dependent variable, and this will be function of y. So if we make this, then what we are looking for is this structure for the linear form. Okay? So this is what we are going to take. Okay? So we take this equation and make it into dx over dy. So let's start with make this becomes dy like this. Okay? And then divide all by y and move some parts to the left. So, well, let's take canceling this and make this over y. Okay. Now this becomes, it becomes plus 2 over y and then x and then equal e with power of y. Now we are having the same structure with the linear differential equation as usual, but we switch x and y. Okay. So we are having x as dependent variable and y is independent variable. It's okay. We can have many variables also using this way. So do not limit yourself to dy over dx, okay? Because we can have many variables, okay, as we want. So from here, then you can follow up with this p, and then you can write down your supposed to be the integrating factor. And this is 2 over y dy. And this will become 2 ln y, or we have e ln y squared, or we can simply say this is y squared. Okay, we can have this. Okay? So this integrating factor we can simply multiply with y squared, and y squared. Okay, and then we can have now the product form d dy. We reverse the product rule. We are going to have y squared and x, right? Dx dy, yeah, right? Okay. This maybe erasing this with this to make it clear. Okay. So this equal to e with power of y squared. And now we can integrate both sides. And again, we need to have some references from our calculus techniques from our previous lecture. Especially for the right side, okay? For the right side, this one. I think you can try to substitute or integration by part, or maybe integration by part will be faster in some way. Well, you can choose which method you prefer, but I will show you this method if you want to use my way. I did explain this method in my calculus class. This is integration by parts, but with some we usually just simply make a table to have a good structure for the integration by parts, okay? Rather than using the u phi minus integration phi du and so forth. This is actually the same. It's the same, but we making repeatable though. So This is the differentiate, this is integrate. So this will be the one that we are going to differentiate, and we have until 0, so we stop here. And this is the one that we integrate because it's e, then it's all e with the same y. There is no chain rule here, so it's still the same. So we are going to have in the answer, yes, yeah, a little bit review on your calculus. Okay. This will be equal to y squared e y, and then minus 2y with ey, and then plus 2ey, and then plus constant. Okay. And then the solution will be in x now. Okay. X, we divide with y squared, so this will be ey minus 2 over y ey plus 2 over y squared ey plus c over y squared. Or if you want, because it has the e power y, we can have 1 minus 2 over y plus 2 over y squared, and then plus c over y squared. Okay. Well, both okay. If you want to stop here, it's also fine. If you want to maybe make maybe more clean, I think also fine. Okay, the rest I will attach to the Moodle later. Okay. Yes. Hmm? Transient terms. Oh, yes. I forgot to mention transient terms. Good, good. So transient terms. Transient terms is when your independent variables approach infinity and the whole thing becomes 0. Okay, so in our case is if we look on this constant here, when y is getting infinity, the whole thing becomes 0. Okay, so we can say that, or maybe we can say this becomes 0. So we call this the transient terms. Okay. Yeah, good call. I almost forgot. Sometimes you can see clearly from the structure the transient terms. Sometimes maybe not really clear, and maybe there's no transient terms. It's also fine. It, uh, we don't really require the transient term to be in the equations, okay? But we can have. Okay, I will move to the new techniques. I think we can just have the introduction one, okay, the substitutions technique. The full technique will be next week. We need a 2-hour class to explain. So the substitutions, if you remember the substitutions in integrations, it has some similar vibes. Okay? We are going to substitute with some new variables. Okay? And the idea is to help us solving the whole equation. So imagine that we have dy over dx let's say we are having a specific function of xy. Okay. And let's say we have our y that is in another, let's say, a function g, and this y or this function g is having two variables x and u. Okay. And u is a function of x, let's say h of x. Okay. So if we want to derive these equations, okay, and with the chain rule, with the partial derivatives, we are going to have and this will have the du dx. Okay. So if we see clearly that this what's happened with this dy over dx, we can say that this will be x, okay, and y is, remember that we have g. So let's try to see from another angle. We can write x and then g, and then g is a function of x and u, and then we have gx x u plus gu. This is partial with respect to u. So we have du dx because of the chain rule. Okay, remember the chain rule? Because this is actually d du, so we have another du to make out and make this equal to dx. So after solving, we're going to see that the du over dx, the du dx will have a function, let's say function capital F. So we are not sure what kind of function, but we just take out as f. Okay. So we'll have this x and u in a variable. So if we can determine a solution in terms of u, okay, maybe another function, let me write with psi of x, then the whole solution of the original differential equation, the first one, is according to this u, we are going to have g and then x, and then this is u, but we are going to write in terms of new function phi. So what this whole lines equations means? So which means if we can determine some function or some new variable u, and we can relate this u with our original differential equations, and with some chain rule, we can force out this differential equation to be simplified and have a solution. Okay. Okay. Now to begin the next sections, okay, and then connecting this techniques. We haven't yet observed the techniques, but this is just the intro. We need to, again, similar to what we have before, we also have the homogeneous equations, and this is also uh, going to be important in this section. Okay, let me write the definition first. Okay? So if function f possess or has the property that when you have f and then we have some multiplication factor tx and ty, so t is multiplication factor, this will equal t with power of some alpha of the function x, y for some real number alpha. So if we have this property, then f is homogeneous function. Homogeneous function of degree alpha. So what does it mean? So for example, if we have a function of two variables, x cubed plus y cubed, okay? If we check the tx, so if we put tx, ty, and if we look at the component becomes, should be this, ty cubed. We know that this can be t cubed, and then we have x cubed plus y cubed. And since we have this degree 3 for the equations, we are going to have the equations is homogeneous function of, or maybe functions, right? Function of degree 3, okay? Well, if we have, let's just adding a constant. If we adding a constant, let's maybe +1, and it's not a homogeneous. So let me write here, it's not homogeneous. So we are going to see the homogeneous by this multiplication factor, okay? And remember the exact equations. We have m and n, right? We also can decide, or we can determine that it is also homogeneous. I'll write in the bottom here. But if you want to write this first, let me wait for your writings. Okay, so remember the exact equation. You have the m, you have the n, right? You have m dx and n dy, right? Now, if we know that we can decide the homogeneous from these explanations, then we can also set whether m and n can be homogeneous. Okay, so we can have some multiplication factor using this t to check whether the m and n is homogeneous. So when you have a structure like exact equation, we can also decide the homogeneity of the equations. Okay, so if we have the remember the m xy dx plus n xy dy. Okay, maybe equal to 0, right? So we can say this homogeneous if, so let me, homogeneous if both m, maybe using blue, m and n are homogeneous, each homogeneous functions of the same degree. Okay. So we need to make sure that the degree is the same. Let's say the degree just like a real number alpha, like the previous one. So if m and n are homogeneous of degree, let's say alpha, we can write that m xy equal to x with power of alpha m and this is 1 and u and xy and x alpha and this is 1 and u, where we have our sub that the u is y over x. Okay, so we can rewrite a new structure here if we let u is y over x. Okay, this is just to see what will be. Okay, because the substitutions later on, the techniques, we are going to have y over x or using maybe x over y. Okay, the idea is to have a good structure in chain rule. We will see later. Okay, and then we have m xy, and then this is y with power of alpha, and now we have v and 1. Okay, so we are going to switch the roles, switch the x and y, and n okay, where v is x over y. Okay, now from this new structure, when we sub with u, let's put all the structure into this m and n in these exact equations. Okay, so we put this 2, this 2, going here, going here. So each one will make a new structure. Okay, maybe let me wait for a couple of minutes. You can write for a moment. Okay, it seems like why we are doing this. Okay, but if we try to look at the structure, we are going to see something happen. Okay. So the idea, we have x, y, and then we have later u. The objectives, we are going to eliminate either x or y, and then change the whole equation become xu or yu. That's actually what the substitutions direction. Okay. Now, if you look at the structure, okay, so from this m, let me write again this m xy dx plus n xy dy is equal to 0. So we can write x alpha m1u. Let's just use the u first, not v. Okay, and then this will be dx, and then plus this is x with power alpha, and then n 1 u, and then dy, and then equals 0. Or simply, if we just take on the look at the m, we can just simply write okay, where u is y over x, or we can write u is y is ux. Okay, now this y we can rewrite in terms of dy. So we use differentials and then use product rule for ux. So this will be u dx and then plus x du. So it will complete our substitution. So we are going to substitute all the things that has y or x. It depends on the substitution. For this y over x, we are going to substitute this dy. And then the whole thing becomes just x and u. Okay, that's the idea. Now this becomes m 1u dx plus n 1u dy. Dy, I will change dy becomes this. Well, let me write here. So let me put u dx and then plus x du equal to 0. Now let's multiply the n with this, and then we group the dx together and du together. Okay. So group the dx is m1u, and then plus the n and u, right? But let me write u first and then n. So this will be dx, okay? And then plus x n 1u du, only one, right? And then it's equal to 0. So what are the things that need to be solved from here? We are going to have separable differential equation. So that's the whole procedure. So the idea, we are going to substitute either with u or v, depends on which x or y that you want to substitute. And it also depends on the function, and we are going to see very soon in the example what kind of example we have or what kind of function we have. So the idea, we are going to have either u and x or v with y, but at the end of the day, from this part, the next procedure is supposed to be the separable differential equations. Well, you can solve, or maybe you can rewrite this and maybe divide all by x and then move here. We'll just going to show you what will be. The structure becomes dx over x plus n du, and then m 1u plus un 1u, and it's equal to 0. So it's separable. One side is du, one side is dx, so it's separable, right? It seems a little bit complicated because we are using the symbols, but in the terms of the real functions that we might have, it will be very practical, very practical. Okay, and the way you maybe take on some questions, you will see the pattern, which substitutions you will take. Okay, but it's important to know by the end of the substitutions, you need to have a separable differential equation. That's the goal. So you substitute the another variable to make the whole thing inside become separable. That's the idea. Okay. So let me write here. It's becoming or becomes separable. Separable differential equations. Mm-hmm. Oh, zoom out, right? Maybe from where? From here? I think examples. I think I will give you next week. Okay, I will stop until here. Okay, I will give you next week example because I think maybe not really much time because there will be some equation that is uh, it's substitution, but it's really specific. We call Bernoulli equation. Okay? That will be next week. Okay. So this one u that's after substitute. Okay, after substitute. Okay, maybe any questions? Or maybe in your homework, which part you think need to have more review? I think the review should be more about some techniques in calculus. Yeah, you need, you need to remember, yeah, rememorize one more time. But I'm not sure. Maybe in your next courses, because you will also use the differential equations in in some courses in the future. Yeah. So I'm trying to give you um, topics that, in terms of mathematics, more general. So I will not going into too much to engineering or maybe to some maybe chemistry because there is some part that can be done in differential equation. But I will give you like really basic fundamentals that you can apply to most cases. Okay, to most cases. Okay, but maybe some models that simplified. I think I can show you. Okay, maybe some a little bit like mechanical harmonic vibrations that can have some models. We can have that as well. Okay, but not really going too much too details. Okay. Okay, as usual. Okay, as usual, we'll have the feedbacks time. Okay, the feedback before our class ends. This about the exact equation. I hope still remember. You can take notes. Let me make bigger. Okay, wait for a moment. Okay. I hope still familiar with the exact equation. Okay, the m dx and dy equals 0. And then inside you have how to get the solution, how to check the exactness. Okay. 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 So only two questions. Okay, I think that's all. Okay. So you have differential equations, and your goal is to find the constant k, so the differential equation is exact. Okay. If you slowly write down, you will get eventually, and you will see it's actually not really long. It's actually really quick, really quick. Actually, really quick. Yeah, 6 students. Wow, very fast. But you can take slowly for this one. Okay, already 16, 17, 18, 19, okay, 21, 22. Uh, is it all? Okay. Yeah, okay. Very good. The answer is 10. You will see that this has 40 and 4. So you can just take it that as 10. Okay. Okay, who is Tom? Who is Tom? Oh, okay. And who is Tinky? Tinky, Tinky. This one, Tinky. Anyone? No? Okay. Okay. Second question. Let's start. Okay. Sorry, it's a little bit long. I give you 3 minutes for almost 4 minutes, but not sure it's okay or not. Should be 5 minutes, but I want to make it mm, faster. Yeah, you can check the option, but I make the options to be okay for the points. So if you check the 40, it's all correct. It's all correct. I don't know. Can you guess? I don't think so. Well, first check the exactness, and it's not exact. Well, I'll give you a little bit complicated just to make sure that at least you can try. Okay, you can try, and maybe uh, after the class you can try at home if you want. Yeah, not exact. So you need to find the integrating factor from m and n. So finding my and nx. So and then minus this two, and you can divide with m or n, and find which one is appropriate, and then that will be your integrating factor. Then you need to divide with m, right? Divide with m for integrating factor, but I don't think the time is enough if you find the integrating factor. Yeah, but let this question be your exercise, okay? Yeah, good, good. Oh, 19, who's 19? And oh, 19, who is 19? Oh, okay, good, really good. Okay, as usual, don't forget to write your ID. If you have any suggestions, you can also write. Okay, and that's all for today's class.